Hello, chemistry class 11th students and friends. Assalamu alaikum. You are watching NPTEL chemistry E class and I am your chemistry detective with one new chemistry class 11th NCERT problem. In this problem, we have to determine molecular formula of compound, and compound is basically an oxide of iron. And in this compound it is given that mass percent of iron and oxygen are 69.9 and 30.1 respectively. First, have in mind that molecular formula is the formula of a compound that expresses the actual ratio of mole atoms of various elements present in it, and empirical formula is the simplest formula of compound and it expresses the simplest ratio of mole atoms of various elements present in it. Here we have to determine molecular formula. Here we have to determine molecular formula, and idea is that molecular formula and empirical formula are related by this equation. Molecular formula is equal to N into empirical formula. Molecular formula is the actual formula of chemical compound and it expresses actual ratio of mole atoms of various elements present in it. Empirical formula is simplest formula of chemical compound. It expresses simplest ratio of mole atoms of various elements present in it, and both are related by this equation. Molecular formula is equal to N into empirical formula. Right? I can now say that determination of molecular formula actually involves two steps, and step 1 we have to determine empirical formula. In step 1 we have to determine empirical formula, and how it is done, we have already done one numerical problem on it. Determination of empirical formula involves knowledge of mass percent of elements, molar mass, then we calculate number of mole atoms, then make that simplest, then make that whole number. And step 2 is determination of N. Determine N. Here what is determined? Simplest whole number ratio of mole atoms. During determination of empirical formula we have to determine simplest whole number ratio of mole atoms of all the elements present in compound. And how N is determined? Remember that N is equal to molecular mass, ratio of molecular mass and empirical mass, or empirical formula of mass. N is common factor and N is equal to ratio of molecular mass of compound and empirical mass of compound. And for simplest case is when molecular mass is equal to empirical mass, then N is equal to 1. For simplest case N is equal to 1 and molecular formula of compound is equal to empirical formula. I said we have to determine molecular formula. Molecular formula is related to empirical formula of compound by this equation. From this equation we can reckon that determination of molecular formula involves two steps. The first involves determination of first empirical formula. Here we are interested in finding simplest whole number ratio of mole atoms of all the elements present in compound. Step second involves determination of this n, which is common factor, and n is calculated using this formula. N is the ratio of molecular mass and empirical mass. From empirical formula you can determine empirical mass by adding atomic mass of all the atoms present in empirical formula. Molecular mass is either given or vapor density is given, because molecular mass is equal to twice vapor density, and for simplest case molecular mass will be equal to empirical formula mass and will be equal to 1, and for such compounds molecular formula is same as empirical formula. And with these ideas I will try to solve this problem now. Element, I will write elements in same sequence as are given in question. Element is iron and element is oxygen, and in first row I will write their mass, given mass. I have already told you that considering 100 grams of compound, given mass percentages represent given mass of element. So for iron given mass is 69.9 and for oxygen given mass is 30.1. In second row I will write their molar mass. Molar mass of iron, both are elements, and their molar mass is equal to their gram atomic mass. Gram atomic mass of iron is approximately 56 and gram atomic mass of oxygen is 16. In third I will calculate number of moles, their moles, and you know number of moles. Moles are calculated by calculating the ratio of given mass and molar mass. So here moles will be equal to 69.9 divided by 56 for iron, and for oxygen number of moles will be 30.1 divided by 16. It comes equal to 1.24 and it comes equal to 1.88. We got number of moles of iron equal to 1.24 and number of moles of oxygen is equal to 1.88. So I can also say like this, we got ratio of mole atoms 1.24 is to 1.88, but it is not simplest. We will make it simplest ratio. Simplest ratio, I have already told you how to make simplest ratio. Divide both by smallest of them. Smallest is 1.24, so I will divide both by 1.24. 1.24 here and 1.24 here. 1.88 divided by 1.24. It will come equal to 1 and it will come equal to 1.5 approximately. Now I got ratio of mole atoms of iron and oxygen in this iron oxide equal to 1 is to 1.5, but this is not whole number atomic ratio. I will make it simplest whole number ratio, simplest whole number atomic ratio. For that I will multiply both by some integral value such that both become whole number. I will multiply by 2 here, it will become 2 ones are 2, it will become 1.5 into 2, it will become 3. Therefore I am now in a position to write empirical formula of this compound. Empirical formula of this compound is equal to, I will write elements in same sequence as are written in question. Given in question, first iron then oxygen, and for iron there are 2 mole atoms in its simplest formula, and for oxygen there are 3 mole atoms in its simplest formula. Therefore, empirical formula of this oxide of iron is Fe2O3. Now I will go for determination of its molecular formula. Now I will go for determination of its molecular formula. I will move here, as I have got space here. I have already told you that molecular formula is equal to n multiple of empirical formula. Empirical formula I have got. Now I have to determine n. N is equal to ratio of molecular mass and empirical mass. Empirical mass I can easily calculate from empirical formula. Empirical mass is equal to 2 into, for iron atomic mass is 56, 2 into 56, plus for oxygen 3 into 16, and it is approximately equal to, I have already calculated it, it is approximately equal to 160. Empirical formula of oxide of iron having empirical formula mass of oxide of iron of having empirical formula Fe2O3 is 160. Now molecular mass is not given in this numerical problem. Molecular mass of oxide of iron is not given, neither vapor density is given. Neither molecular mass is given nor vapor density is given. So we cannot calculate value of n. However, I have an idea that if I consider that this compound represents simplest case, then for it n is equal to 1, and then for it molecular mass will be equal to its empirical mass, n will be equal to 1, and molecular formula will also be equal to empirical formula. So I will write that compound represents simplest case, compound represents simplest case of n is equal to 1. Therefore its molecular formula will be same as empirical formula, and molecular formula will again be equal to Fe2O3. This is its answer. If I may recall this numerical problem one time for you, in question it was said that we have an oxide of iron, and for this oxide of iron, mass percent of iron and oxygen are 69.9 and 30.1. Now we needed to determine molecular formula of this compound. I said first have in mind what molecular formula of compound represents. It is the actual formula of compound because it gives actual ratio of mole atoms of all the elements present in it. And then there is another formula called empirical formula. Empirical formula is simplest formula of compound because it gives the simplest ratio of mole atoms of all the elements present in it, and both are related by this equation. Molecular formula is equal to n into empirical formula. N is common factor. For example, for glucose C6H12O6, actual formula is C6H12O6. Common factor between 6, 12 and 6 is 6. Simplest formula will become C1H2O1. So common factor here is 6. This n represents common factor, and EF is empirical formula. From this equation we reckon that determination of molecular formula actually involves 2 steps. First, determination of empirical formula. Here we are interested in finding simplest whole number ratio of mole atoms, and then in step second we determine n, and determination of n. For determination of n we use this formula. N is equal to ratio of molecular mass and empirical mass, or I said n is equal to twice vapor density by empirical mass. And for simplest case, if compound represents simplest case, n is equal to 1. For simplest case, n will be equal to 1, and molecular formula of compound will be same as empirical formula. I used these ideas in order to solve this numerical problem. I wrote first element side by side in same sequence as were given in question. In first row I mentioned the mass of for each element. I said that considering 100 grams of compound, given mass percentages of elements represent their given masses. So for iron, given mass is 69.9 and oxygen 30.1. In second row I wrote their gram atomic mass. For iron it is 56, for oxygen it is 16. In third row I calculated number of mole atoms of iron and number of mole atoms of oxygen. It came equal to, ratio came equal to 1.24 is to 1.88. I said it is not simplest ratio, make it simple by dividing both the numbers by smallest of them. Then I got ratio 1 is to 1.5. I said it is not whole number atomic ratio, make it whole number atomic ratio by multiplying by some integral value. I use 2 as multiplying factor, 2 into 1, 2 into 1.53. So empirical formula, while writing empirical formula I wrote symbols of iron and oxygen side by side in same sequence as were given in question. For iron I wrote its number of mole atoms, and for oxygen I wrote its number of oxygen mole atoms. Therefore empirical formula I got is Fe2O3. Since I needed to determine the molecular formula, and for determination of molecular formula I must have molecular mass of this compound, but neither molecular mass of compound is given nor vapor density is given. I got idea that compound must represent simple case with n equal to 1. In this case molecular formula will be same as empirical formula. Therefore molecular formula I was able to determine equal to Fe2O3. This way you can solve numerical problems of similar sort in which you have to determine molecular formula of any compound. Just follow this procedure, you will be able to solve that numerical problem. Thank you. This is what I have got for you in this short session. Take good care of yourself. Allah Hafiz. See you tomorrow with one new chemistry problem.